Hi, year 9. We're going to go ahead and look at 7E, which is negative indices. And what winds up happening is if you're given, for example, let's say a to the 6th divided by a to the 9th. What we're told is our rule from a few days ago was when you divide terms, we subtract our indices. So what we wind up getting here is 6 minus 9, so we get a to the negative 3rd power, which is a negative index. And this is new for us. We haven't really worked with negative indices before, but let's just see what happens here. If I had a to the 6th and I divide vertically by a to the 9th, that means I have 6 a's. So a times a times a times a times a times a. And I divide by 9 a's. So a times a times a times a. 1, 2, 3, 4, 5, 6, 7, 8, 9. What winds up happening is I can reduce one at a time. So a divided by a is 1. A divided by a is 1. A divided by a divided by a divided by a, and a divided by a. So all of these quotients reduce to 1, but now I still have 3 a's that are multiplying in the denominator. So I wind up with 1 over a cubed. So if you notice, I still get this 3 in both ways that I do this question. But here it's written as negative 3, and here it's written as 1 divided by a to the 3rd. So when we get negative indices, what winds up happening is we actually can write them 2 ways. And one way is writing it with negative indices, which is what we did here. And the other way is to rewrite expressions that have negative indices with positive indices. And that's where we have it written right here. We have a positive 3, but notice it's in the denominator. So if we rewrite a negative index as positive, it winds up switching from numerator to denominator, also known as the reciprocal. So we wind up finding the reciprocal. So for example, let's say you guys were given something like 1 over a to the negative 5th. Well, notice here the negative is in the denominator. So now when I rewrite it, the reciprocal would be to put the a to the 5th in the numerator, and that switches. All right, so what we wind up looking at is a negative index just tells us that that term really belongs in the opposite position. So here, if it's already sitting in the numerator, it really belongs in the denominator. Whereas in my next example, when it was in the denominator, it's negative index, it winds up in the numerator. So for our first example, we're going to rewrite the following as fractions, and we want to write these with positive indices. So I have 3 to the negative 2. In order for me to rewrite it, I'm going to move the 3 to the denominator. And as soon as I move it to the denominator, I can write it as a positive 2. And I didn't have another number, so I'll put a 1 as my numerator. So 3 to the negative 2 is actually 1 divided by 3 squared. If I look at my second example, I have 5 times 4 to the negative 3rd. So I'm going to tackle this part first, the 4 to the negative 3rd. That means I really want to write 4 cubed in the denominator. This 5 is just a regular 5, so it's going to sit in the numerator. It does not have a negative index, so I don't have to move it anywhere, so it stays in the numerator. With the second example, I'm going to rewrite the following with positive indices. So look at this is what happens here. I start in the denominator with a negative index. So again, anytime I have a negative index, that means I just need to write it as the reciprocal in order to write it positive. So that means 2 to the negative 3rd is going to be written in the numerator with a positive index. So now the 1 is in the denominator. So 2 things just happened. I switched numerator to denominator, and my negative turned into a positive. So let's just clean this up a little bit. 2 cubed divided by 1 is really just 2 cubed. So I don't need to keep that 1 as a denominator. We assume the 1 is our denominator. And the second example, 7 divided by 3 to the negative 2. All right. So here, the reciprocal of 3 to the negative 2 is going to be 3 squared. However, the 7 does not have a negative index, so it does not need to move. So I'm going to keep the 7 in the numerator, okay? The 3 squared technically has a denominator of 1. But remember, we do not have to write the denominator as 1. So I'm going to just write it as 3 squared times 7. The 7 does not have a negative index, so the 7 is not part of my new rule. I'm just going to leave 7 as 7. So 3 squared times 7. If I actually wanted to evaluate this, 3 squared is 9 times 7 makes 63. There we go. So just to recap, anytime you have a term sitting in the denominator, the numerator is always 1. And therefore, when I take the reciprocal, I'll have a 1 technically in the denominator. However, when we have any other number, remember, there's this other number of 7 here. It is not part of the reciprocal because it does not have a negative index. So we're going to leave it where it is, which is sitting right in the numerator. For our third example, we are going to rewrite 3 times 2 to the negative 4th with a positive power. All right, so let's take a look. 3. Again, 3 does not have a negative index, so I leave it as is. Times 2 to the negative 4th. If I want to write 2 to the negative 4th, I need to write it as a reciprocal. Then I can write it with a positive power. I don't want to leave it like this though, because 3 times 1 divided by 2 to the 4th really is going to let me multiply the numerator times the numerator. So 3 times 1 is 3 over 2 to the 4th. And if I continue to simplify, 2 to the 4th is 2 times 2 times 2 times 2, so I get 16. So 3 times 2 to the negative 4th is the same thing as 3 divided by 16.